So now that we've done that, what is the next step? The next step is to actually replace these strings with functionality that has to do with persisting data in NS user defaults. So let's do that. Let's do load first. I'll delete these two strings here. So basically in load, I'm going to say NS user defaults, standard user defaults, which is the mechanism we use to interact with user defaults in the first place. And I'm just going to say object for key. And I'm going to pass in the key here. And that is it. Similarly for save object, I'm going to say NS user defaults, standard user defaults, set object. I'm going to pass in the object for key. And I'm going to do one more thing here, which is NS user defaults, standard user defaults, synchronize. Let's see. And we have no errors, which is great because it means that I didn't mess up. And if you look at, let's say you option click to inspect some of these things, standard user defaults you can see is sort of a shared singleton defaults object. You can think of it as really just a key value store or a dictionary. And this is the method that gets an object for a particular key if there is one. And yet, as you can see, just like our function here, load object for key returns an optional any object, so does this one. Which means that we don't need to capture this in some kind of local variable here. We can just return the result of it directly. Save object is very similar. We're accessing the standard user defaults object, and we're calling set object, which sets the value of the specific key to this particular value. And then we're calling synchronize, which writes any modifications to the persistent domains to disk and updates all unmodified blah, blah, blah. So this is basically, it's keeping our changes in sync. So there's some sort of caching layer behind the standard defaults or the user defaults interface here. And this is basically saying, I've made some changes. You might have made more than one change. Make sure that they're propagated throughout the user default system so that the values are truly set and available if I want to retrieve them after the fact. So this is very exciting because it completes our implementation of this user defaults cache, which allows us to experiment and see if across sessions our list persists. So let's say I add one item, the word hi. Let's say I stop the app. Previously, we knew that when the app launched again, there would be an empty list. This time, when the app launches, I have the word hi there. And this is great. It means we're doing exactly what we wanted. Let's set another breakpoint here in load and try that one more time. We'll see what we get. So when the app loads, when the list view controller is created, its view loads, we call our load function here. We're going to try to get an object, or nil, out of the load object for key method on our cache. And we see that this is actually equal to some value. If I step over this, I can see that I'm actually able, it's not nil, and I'm able to create an NS array out of it. And I'm creating basically an array, or what I'm getting out of that is an array that has one value in it, and that value is equal to the string hi exclamation point. And that means that I can now convert that to a mutable array, set it to items, and when our table view loads and our cell for row at index path method is called, you'll see that it'll be called for one cell because there's one item in the array, and the item that we grab is that hi string, and we're going to set that to that single cell's text label. So that's great. With that, I mean that's basically the first half of our cache implementation. It's one approach. It's a very, very lightweight approach, yet also very useful. Caching can get pretty complicated. You can get into thread safety issues. Excuse me, my throat's getting a little sore. But it's always a good idea to use the simplest mechanism available that kind of satisfies your acceptance criteria. And for us right now, this does it perfectly because we're able to modify a list, quit the app, return to the app, and see that data in the list. Let's do that one more time. Like if we go to to-do here, let's say we add another item. We hit done. It's added to the list. Now let's say I double tap the home button. That was our other list. I double tap the home button here and kill our app, right? It's totally removed from memory. That means that if the data is actually being persisted to disk, it should show up when I relaunch the application. And it does. So you can do that as many times as you want. You could also, let's say, remove the hi string, hit done, kill this from the multitasking bar. I'm doing that by doing Command-Shift-H, which is also in hardware home, Command-Shift-H. Hit that again. Your list will load, and you'll see the modified contents, the contents after I have removed the word hi. So that's a wrap on the user defaults cache. Let's move on to talking about how to implement the keyed archiver cache.